Assalamu alaikum. We are discussing about the syllabus of 5070 or Igcse, Cambridge Assessment International Examination. We have to discuss today chemical reactions or energy from chemicals. In the topic of electrochemistry, you have discussed how does a cell form and how does cell perform its function. We need a higher electropositive metal along with a lower electromagnetic or electropositive metal to produce the cell voltage. So it would be the cell. Similarly, we know that what is chemical reaction? Chemical reaction eventually chemical process in which reactants convert into products. It means carbon combined with oxygen, burning coal combined with oxygen produce carbon dioxide. So carbon dioxide should be the product, and carbon oxygen both are reactants. Whether two or more reactants can combine to form a product, or two or more substances combine to produce two or more products as well. So, what is chemical reaction? In the previous chapter, mole and stoichiometry, you have discussed the stoichiometric function. Reactants combine together to produce a compound. And by using a simple reactant, you can calculate the amount of any reactant or product as well. So, during a chemical reaction, sometime heat energy is released or energy is absorbed. So, we can say that chemical reaction stands for conversion of reactants to products or a process through which chemical composition of a substance is altered, changed. For example, burning coal combined with air, oxygen, produce carbon dioxide. So the chemical composition of carbon and oxygen just changed. One more example, calcium carbonate when heated, then carbon dioxide is formed along with calcium oxide is produced. So we have one reactant towards the reactant side as well as two products towards the product side. Both are chemical reaction. While during the discussion in the acid-base titration, acid-base metals, non-metals, and the chemical properties of acid, when a metal react with an acid, HCl, nitric, sulfuric, ethanoic, then moderate reactive metals or highly reactive metals can produce hydrogen gas along with a chemical compound which is called salt. Ionic substance is formed because zinc chloride is an ionic compound due to the presence of zinc as a metal, and chlorine is non-metal, so this would be an ionic compound. All these are called chemical reactions, but this is only 100% reactant convert into product. It is a simple chemical reaction. But some specific chemical reaction we have. These types of reactions are known as thermochemical reaction. How can you define thermochemical reactions? So thermochemical reaction are those reactions when reaction proceeds then heat energy is absorbed or evolved during the process. These reactions are known as thermochemical reactions, or just we can say that thermoreactions. For example, when carbon burn in presence of air to produce carbon dioxide, the heat must be absorbed during this reaction. But hydrogen gas combined with chlorine gas, then HCl is formed, then heat is released. Similarly, during the formation of carbon dioxide, heat and light is released. So both the reactions are called exothermic reaction because they release heat. But when a single compound is heated, means decomposition reaction, heat is absorbed. So we can say that we have two different types of thermochemical reaction. Either heat is absorbed or heat is released. If the reaction they proceed by the heat is released, they are called exothermic reaction, while those reactions when they absorb heat energy to proceed, they are called endothermic reaction. Similarly, photosynthesis reaction when plants in presence of sunlight absorb heat, absorb water vapors from the environment, from the atmosphere, along with the carbon dioxide, they produce their glucose and oxygen is released. This reaction is also known as endothermic reaction. Means photosynthesis, also the example of endothermic reaction. But respiration, during respiration, when we inhale oxygen and nitrogen towards our mouth or our nose, these gases can be exchanged in your trunk. It is called lungs. Carbon dioxide can be evolved in your exhale breath. So it must contain the amount of heat along with the carbon dioxide as well as water vapors. So respiration is also the example of exothermic reaction, because when we exhale our breath, it must be the little bit hot. Then we absorb oxygen or inhale oxygen, it must be the cold. So they are two different types of thermochemical reaction. One of them is considered as exothermic reaction, means heat is evolved during the reaction, and endothermic reaction, they must absorb heat during the chemical reaction. Similarly, cooking of food, also the example of endothermic reaction. Heat is needed. Burning of coal, burning of oil, burning of fuels, they are also the example of exothermic reaction. So now, this is the introduction about the thermochemical reaction, and the above, these lines just produce a concept about the chemical reaction. Matter just change into matter, reactants are matter, products are matter. This is simply known as chemical reaction, but we know that all chemical reaction must be taken place in presence of heat or they produce heat also. For example, when a solid substance, solid just change into liquid, so we can say that heat must be absorbed. Because solid change into liquid during melting, it absorb energy, endothermic. Similarly, when liquid can be further heated, change into vapors or gas, they also the example of endothermic. Endothermic, solid to liquid, liquid to gas, energy should be absorbed. But the reaction should alter when the reaction just change from gas to liquid, they must evolve energy. So this is called exothermic reaction. This is exothermic. When liquid change into solid pack, this is also the example of endothermic. No, exothermic. So solid change into liquid or liquid change into gas. This must be the absorption of heat, means endothermic reaction. How can we say that a reaction should be the exothermic or endothermic? Okay. Now, this is the introduction of this chapter. There are two types of changes. Number one, physical change, and number two, chemical change. Chemical changes consist of changes in the structure of matter, composition must be altered, substances react to form new substances. Every chemical change or chemical reaction consists of two parts. Number one, breaking of old bond, it involves absorption of energy, and making a new bond, it involves release of energy. What does it mean? The overall reaction is judged by the difference in the two steps. How? A reaction involving an overall release of energy, the absorbed energy is less, then the release energy is more. The reaction should be exothermic. A reaction having an overall absorption of energy, heat energy, is termed as endothermic reaction. For example, cooking of food, it must be heat must be absorbed. Similarly, in the photosynthesis, heat must be absorbed. But during respiration, when we exhale our breath from the mouth or from the nose, some amount of heat should be released because our breath little bit more than the inhale. It must be called exothermic reaction. So the change in the energy contents of the substance is called enthalpy change, or enthalpy change should be denoted by delta H. Now, chemical reaction. How does a chemical reaction should be an exothermic or endothermic? Bring your calculator for the purpose to calculate something. A chemical reaction, for example, consisting of breaking of older bonds and formation of new ones. Now we have to use this example, which is called decomposition of hydrogen oxygen and the production of water molecule. With a breaking of bond is endothermic, heat must be absorbed, and the new bond when formed, they must release their heat energy. So this is called exothermic. How does we calculate the total amount, and how can we say that this reaction should release this amount of energy or absorb this amount of energy? It is very simple. Listen, guys. Hydrogen is a molecule. Hydrogen is another molecule. This is the molecule. But first, we have to break the bond between these hydrogen molecules as well as oxygen molecules. Otherwise, water cannot be produced. Now, 436 kilojoule of energy is absorbed by the hydrogen molecule. As a result, both the atom in a molecule can be separated into atomic form. One more molecule of hydrogen absorbs 436 kilojoule per mole with a red color shows heat energy is absorbed. Heat energy is absorbed. If a container contains hydrogen and oxygen, when we heat this container, the first former bond are breaking. That is why this reaction is called endothermic. Now 496 kilojoule per mole energy is absorbed by the oxygen molecule. As a result, oxygen molecule break into hydrogen oxygen atoms. Now, what happened? When oxygen combined with one atom of hydrogen, 485 kilojoule per mole energy is released. So, one OH bond is formed, second OH bond is formed, the two OH bond is formed. They are the new bond formation. That is why energy is released. While the hydrogen molecule has been broken down by absorbing energy, we have three different molecules, two hydrogen, one oxygen molecule. What happened? One molecule of hydrogen absorbed 436 kilojoule per mole energy, and they became in the atomic form reactive. Similarly, oxygen molecule can be broken down by absorbing 496 kilojoule per mole energy. This is the evidence. This is the specific data. So during the calculation of the bond making and bond breaking, energies values should be given. Now, one oxygen atom is remain along with the two hydrogen. One more molecule of water is formed. So, with the two more new bonds are formed. 485, 485. So, now what should you do? Add these numbers 436 plus 436 plus 496. This is total amount is 436 plus 436 plus 496. So the sum of these numbers is 1368. So this is color is red. It means that it must be the endothermic. Heat is absorbed. Heat absorbed. Okay. What happened next? Now we have to sum these values in the blue color. 485 multiply by 4 because 4 bonds are new 4 bonds are 4. So 485 multiply by 4, the product is 1940. 1940 is the negative sign because heat is evolved negatively, while the 1368 is positive. So they are two different numbers. How can we subtract them? How can we subtract them? Minus 1940 while plus 1368. So plus 1368 is the positive red color. What happened? What is the difference between them? By using the calculator, 1940 minus 1368, answer is minus 572. Minus 572. This 572 energy is released. The positive number heat is absorbed is less than the heat which is evolved. So now we have to proceed. This is the difference of 572 minus sign, and when we divide 572 by 2 because two water molecules are formed, if I needed to calculate for the formation of one molecule of water with a 572, this amount of energy has been released by the formation of 2 moles of water. When we needed 1 mole of water, this number is divided by 2. As a result, minus 286 kilojoule per mole energy is obtained, is released during the formation of 1 mole of water molecule. Okay. Now we can discuss this topic again in this manner by using the 436 kilojoule energy is needed for the breaking of this hydrogen molecule, 436 again for this hydrogen molecule, and 496 for oxygen molecule. So beta sum of these three numbers 436, 436 plus 496, it is the total of 1368. Positive sign shows heat energy is absorbed. So beta when molecules has been broken or have been broken, they must absorb heat energy. So total energy is 1368. But what happened now when oxygen hydrogen bond is formed? When oxygen hydrogen bond is formed, minus 485 kilojoule energy is released. Number one. Then again, minus 485 kilojoule energy is released for the making of one more bond. Similarly, minus 485 and again minus 485. These four numbers, when we add, they produce a substance minus 1940. The minus means heat exit, plus means heat absorb. When we when we produce a difference minus 1940 plus 1368, overall change is found minus 572 kilojoule. But this 572 is needed for the formation of two water molecules. It means when two molecules of water, 2 moles of water are formed, 572 kilojoule energy is released. What happened? When 572 is divided by 2, then answer is minus 286 kilojoule per mole. So K kilojoules per mole. This is the unit for the formation of 1 mole of water. So in the previous section, we have discussed how does a reaction is exothermic or endothermic. Now, exothermic reaction, how can we define exothermic reaction? This is a simple way to define. These reactions absorb less energy during bond breaking. They release more energy during formation of new bonds. It means exothermic reaction are those reactions they emit heat energy because they absorb less energy but they release more energy. Now, exothermic reaction we have discussed. These reactions absorb less energy during bond breaking, but they release more energy during formation of new bonds. The graph between the time of reaction and the change in energy is called energy profile diagram. In this reaction, enthalpy change delta H is negative because H2 is less than H1. The value of delta H is negative, which means an exothermic reaction. Keep this thing in your mind. This is the starting point, or reactant have some concentration here, 1 mole, 2 mole, 3 moles, and so on. But when reactant convert into products, so some amount of energy just release. That is why reactants just convert into product by releasing the heat. So reactants are more and the products are less than the reactant. That is why H2 minus H1, H2 was less than, H1 is greater than. That is why when H2 less than the H1, so beta sign of delta H is negative. This is the level. This level is known as activation energy EA. The amount of energy which is required for the successful collision between the molecules of reactant for converting them into product, this amount of energy is known as activation energy. So some examples are there for exothermic reaction, or it has been discussed little bit. So exothermic reaction examples are combustion reaction. All combustion reactions are exothermic. Fossil fuel, petrol, gases. Burning of carbon is also the example of exothermic. Fuel cell in the future. Hydrogen, oxygen, when they combine, they produce water. Along with the heat is released, and this heat is used to mobilize the vehicles in the future, cars and vehicles. Fuel cell. Respiration is an example of exothermic reaction glucose of our body burned in presence of oxygen. This oxygen has been inhaled in our lungs by the mouth or by the nose. All neutralization reaction when acid react with the base or vice versa. This is called neutralization reaction, and all neutralization reaction are the example of exothermic reaction. Now the fossil fuel means beta fossil fuels means petroleum, crude oil. So beta these petroleum can produce the energy. They are the energy source and non-renewable energy source. What are fuel cell? This is fuel cell using of hydrogen to generate electricity. Hydrogen reacts with water to form oxygen, react with hydrogen to produce water. During this a process of ionization, this process can be started to generate electric current. Advantages: no water, no pollution produced, look like carbon dioxide, carbon monoxide, rechargeable. It is also called renewable. But the disadvantage is production of hydrogen is a costly process. Handling of hydrogen is dangerous and it is a combustible gas. So, but the fuel cell is the advantages and disadvantages, but there is no harm to produce any kind of pollution in the air at all. Next one, metal oxide react with acid. It is also the example of neutralization reaction. So this is called exothermic reaction. Now, what happened during the endothermic reaction? Reaction absorb more energy, bond breaking, but they release less energy during bond formation. The graph between the time of reaction and the changes is called energy profile diagram. And now you can see that reactants are less than the product. So with the H1 is less than H2, so H2 is greater than H1. That is why sign of delta H should be positive. We can say that enthalpy change, sign of delta H should be positive. So this is the energy profile diagram of endothermic reaction. They are the examples of endothermic reactions. All decomposition reaction, when a single compound is heated in absence of air, they produce their product. This is called decomposition. All decomposition reactions are the example of endothermic. When ionic compound dissolve in water, this is called solution making, means dissolution, they must absorb heat energy. Similarly, photosynthesis is the glucose production by the plants in presence of sunlight. Carbon dioxide from the air, water vapors from the air can be absorbed by the leaf in presence of sunlight. In presence of chlorophyll, they produce glucose. They are the examples of endothermic, means decomposition, dissolution, and photosynthesis. Now, this is the comparison between exothermic or endothermic energy profile diagram. Now you can see that this is the left hand side diagram. It must be the endothermic reaction because reactant are less than the product because they just absorb amount of energy clearly. While the right hand side diagram is called exothermic energy profile diagram because reactant convert into product and during this conversion heat energy is released. That is why they are called energy profile diagram. In endothermic, energy increasing, exothermic, energy decreasing, endothermic absorb heat, exothermic evolve heat. Okay.